Good morning. I hope you guys had a great weekend. And if you're a Liverpool fan, it must have been better for you. But some of us United fans, things didn't go our way. But that's okay. So today I want us to look at applications of quadratic equations. Last week we looked at graphs of quadratic equations. We looked at solving quadratic equations by factorizing. And I hope you remember that when you're solving a quadratic equation, what you're really looking for is the x-intercepts, right? And the x-intercepts are the points where the graph cuts the x-axis. So those 2 points, those are your x-intercepts, x1 or x2. And a quadratic graph could have either 0 x-intercepts or 1 x-intercept or 2 x-intercepts, depending on the type of equation that you have. So this is just a recap of what we did last week. And how you are doing this is you are factorizing and then solving. One way that you solved is you use the zero property, which says that if the product of two numbers is equal to 0, then either one of those numbers is 0. Now, one of the questions that disturbed you guys a lot, which was an easy one, is if you had something like x squared plus 6x is equal to 0. Because this is not like a full quadratic equation, most people got confused here. But all you have to do was factor out 1x, and then you have x plus 6 is equal to 0. And then you just use this idea that if two numbers multiplied are equal to 0, then either one of them is equal to 0 or the other one is equal to 0. And then you take away 6 and you're left with x is equal to -6. So this is a recap of what we did last week, and if you have any questions on that, please ask. Don't die alone, please ask. Today we'll look at some applications of quadratic equations. So what we'll start with today will be, just easy interpretation and comprehension questions like this one. But tomorrow and Wednesday we'll get into it a little bit more and look at some more applications like projectile motion, graphs of projectiles, and some other applications like fencing and perimeter and area. And this is just reminding you that you have your unit test on Friday, so that's exciting news. So yeah, let's get into it. If my first example says the product of two consecutive integers is 132, find the integers. Now, as soon as you see this question, you can say, well, I can do try and error since they are consecutive integers, and I hope you guys remember that integers are the numbers 1, 2, 3, 4, 5, 6, and so on and so on and so on up to infinity. If they are consecutive, it means one comes after the other, right? One comes after the other. They are consecutive. So if the product is 132, all I have to do is keep multiplying. Is it 1 and 2? No. Is it 2 and 3? No. Is it 3 and 4? No. So you can just keep multiplying and see which two numbers add up to give you 132. I'm pretty sure it's 11 and 12, because when you multiply them you get 132. So you could just write your answer as 11 and 12 and show your work that my work was I kept multiplying different numbers until I got them. That works, but a cooler way is to use quadratic equations to solve it. So you can say, if I know that these two numbers are consecutive, let one number be x, right? So if one number is x, and then the next number is going to be, because they are consecutive, the next number is going to be x plus 1, right? X plus 1. And the question says that their product is equal to 132. So all I have to do is multiply these numbers. So I'll have x multiplied by x plus 1 is equal to 132. Now I will open up x squared plus x, and I'm going to is equal to 132. Then I'll bring the 132 this side such that I can have a proper quadratic equation. I'll have x squared plus x. When the 132 crosses over, it becomes negative, is equal to 0. And now I can solve by putting 1x squared here and negative 132 over there, right? So I know that these factors are going to be, x and x. And then over here, I know that these factors of 132 are 12 and 11. but I need to figure out which one has to be negative, such that at the end of the day I have x as my result, because I'm going to add them over here. So this is 12x and this is 11x, so the 11 has to be negative because I need to get a positive x. So then I'll write my factors as x plus 12 and x minus 11. So that's my factors. X minus 11 and x plus 12 are equal to 0. Now I'll use either x minus 11 is equal to 0, which means if I add 11 both sides, which means that x is equal to 11. Now all I need to do is find one of the numbers, right? If I found one of the numbers and I know that this x is 11, then the other number has to be 11 plus 1, which will be 11 plus 1, which is 12, right? So then I know that my integers here are 11 and 12. Like I said at the beginning, you could have done this by trial and error, but it's much cooler to do it with quadratic expressions or equations. Let's look at another one. The product of two consecutive odd numbers is 63. And maybe before we move on to example 2, on this example 1, you guys can say, why do we need to do quadratic equations? Well, what if this product was something ridiculous like 10 million something, or like 10,000 or 1,054? I don't even know if that's a thing. But if it was a big thing like that, you're not going to go multiplying each number until you find the answer. This is a much quicker and more beautiful solution or way on how to approach this. So then I'll go to example 2. The product of two consecutive odd numbers is 63, right? Two consecutive odd numbers. The numbers are odd and they are consecutive. I know that my odd numbers are 1, 3, 5, 7, 9, 11, and so on and so on and so on. And I know that you guys can see that these numbers are obviously 7 and 9, right? Because 7 times 9 is 63. This is an easy one to see. But like I said, if you get a bigger problem, like if it was 635, how would you solve it? You would use quadratic equations. So let's see how that works. So this helps because we know what we should get. But you look at some examples where you don't know what you should get, and you have to use the quadratic expressions, quadratic formula, sorry, the quadratic equation. So I know that the two numbers, I'm going to say, let one of the numbers be x, right? If one of the numbers is x, then the other number is going to be, look at this, odd numbers have a difference of 2, right? I just add 2 to get the next odd number. So the next odd number is going to be x plus 2, right? And I know that their product is equal to 63. So I know that if I multiply x times x plus 2 is equal to 63. So I'm going to distribute this out, and then I'll have x squared plus 2x is equal to 63. And I'll bring the 63 over this way such that I have it equal to 0. Because remember, I cannot find the x-intercepts when it's not equal to 0, or I cannot solve it when it's not equal to 0. Okay, so I'm going to put it in my puzzle. I have a puzzle here. This is x squared and this is negative 63, and it has to be equal to 2x. So the two factors are x and x here, and then it has to be 9 and 7 there. But because this is positive, the 9 has to be positive, because this will be 9x and 7x, and so that means the 7 has to be negative and the 9 has to be positive. So my factors are x plus 9 and x minus 7. X minus 7 and x plus 9 are equal to 0. So then I'll say either x minus 7 is equal to 0, and when I add 7 to both sides, I'll have x is equal to 7, right? And remember, all you need to do is get one of the numbers, because if you've got that x is equal to 7, then the next number has to be 7 plus 2, which is automatically 9. So then you just say my numbers are 7 and 9. Like I said at the beginning, this is easy to do because you guys can see that the product has to be 7 and 9. But you will get questions where the numbers are big and it's difficult to think about them, right? So this one says the product of two consecutive even numbers is 168. Same process. Let one number be x, right? If one number is x, the other one is going to be x plus 2, because just like odd numbers, even numbers are also separated by 2, because you have 0, 2, 4, 6, 8, 10, like that. Okay, so so then I have the product x open brackets x plus 2 is equal to 168. I expand this out, and you guys are already pros at this, I bet. X squared plus 2x is equal to 168, and then I can try to look for factors, right? Look for factors. What two numbers can I use to solve this puzzle? Sorry, I'm not yet at the puzzle. 2x minus 168 is equal to 0. And I'll draw my puzzle. This has to be x squared. This is minus 168. And I want them to equal 2x. So the factors are x and x. And what factors of 168 am I going to multiply to get, what two numbers are multiplied to get 168? I think you'll find that those two numbers are 12 and 14. Then they have to add here and give me a positive. So I hope you can see that 12 has to be negative, so that will be negative 12x, and this is 14x. So my factors are x minus 12 and x plus 14. So that is x minus 12 and x plus 14. At this stage, you go and say either x minus 12 is equal to 0, which if you add 12 both sides means x is equal to 12, right? And as soon as you get one of them, this is equal to 12, then the next one has to be 14. So your numbers are 12 and 14. Okay, let's look at even another example. The sum of the squares, this time it's the squares of two consecutive positive numbers is 10, right? This time it's the squares. If you think you can attempt this, go ahead and pause the video and then try it, and then play it again to see if you have the same answers, right? So we have the squares of two consecutive positive numbers is 10. Now again, this is an easy one. I put it intentionally as 10 just so you guys can see that sometimes, wait, is it even 10? 2 squared, wait, plus 3 squared. No, that should not be 10. That should not be 10. Because in my mind I wanted to use 2 and 3. So 9 plus 4 is not 10, it's 13. Sorry about that. So that should say 13. So yeah, again, if you think you can do it, go ahead and pause the video. So the sum of the squares of two consecutive positive numbers is 13. Find the two numbers. Again, you're going to say let one number be x, right? If one number is x, the next number is going to be x plus 1, right? But these guys are telling us that the sum of their squares is 13. So if I square those numbers and I add them together, so if I get the first one, I square it, and then the second one and also square it and add them together, which is what I'm doing here, the answer I expect should be 13. So let's see, this is x squared plus, when I expand this out, I hope you guys remember the product a plus b squared is equal to a squared plus 2ab plus b squared. That's what I'm going to use, right? So that will give me x squared for this one, x squared plus 2x plus 1 is equal to 13. If you don't remember how to do this, you can write this whole thing as x plus 1 times x plus 1, and then you can distribute one by one. You can distribute that, and then distribute that, and then distribute that, and distribute that. Then you will get x squared plus x plus 1. which is the same thing as what I have. I have x squared, which is there. X plus x is 2x, which is there. And then the 1, which is there. So all of that is equal to 13. So I'm just going to collect like terms. X squared and x squared, I have 2x squared plus 2x plus 1 is equal to 13. Now I need to bring the 13 to this side, so I'll have 2x squared plus 2x minus 12 is equal to 0. Okay, so I have a quadratic equation, 2x squared plus 2x minus 12 equal to 0. If I want, since 2 is common to each of these numbers, I can divide through by 2 if I want, right? And then this will simplify to x squared plus x minus 6 is equal to 0. If you want, you can do this, but you don't have to. You don't have to, you can still simplify it at this stage. And then you're going to ask yourself, how can I factorize this expression? What my factor is going to be? And then, alright, so then you go here and say this is x squared, this is negative 6. This will be x and x, and this will be positive 2, and this will be, sorry, it will be negative 2 and 3, because I want them to add up to give me x, right? This will be negative 2x plus 3x. So you know your factors are x plus 3 and x minus 2 is equal to 0, which means that either x minus 2 is equal to 0, and then you add 2 both sides, then you get x is equal to 2. When you get x is equal to 2, you know your first number was x, so that will be 2. The next number is x plus 1, which will also be 2 plus 1, which will be 3. Now I hope you've noticed that in all of these previous examples, I did not use the positive factor, the one that had a positive. The reason being that if I use that positive factor, it is going to give me a negative number. It's going to give me negative 3. So I don't want that, because I know the numbers that I am trying to get are positive, right? So I'll ignore the factor that gives me a negative number. Okay, last example. The perimeter of a rectangle is 36 centimeters. The area of the rectangle is 80 centimeters squared. Find the length of the longer side of the rectangle. So these are so many words, you can look at them and get scared, but what you do first is draw the rectangle, right? The perimeter of a rectangle is 36. So I know a rectangle has length and a width, right? Length and a width. This is the width and this is the length. Alright, they're telling me the perimeter is equal to 36. I hope you guys remember that perimeter is the same thing as all the sides added together. So if I add the length plus the width plus the length plus the width, I'm going to end up getting 36. So my perimeter is going to be 2L plus 2W, because I have L and L, then I have W and W, and it's equal to 36. So I have this equation, 2L plus 2W is equal to 36. I can decide to divide by 2, and then I have L plus W is equal to 18. I have that equation from the perimeter. And then it says the area is 80. Area of a rectangle is length times width, and they're telling me that when I multiply the length times width of this rectangle, I'll get 80. So L times W is equal to 80. Now I'm going to do some interesting substitution that you guys might think is so difficult, but just hold on for a second. From this equation, I'm going to make L the subject. So if I make L the subject, that means I'll subtract W and subtract W and have L is equal to 18 minus W, right? So if I have L is equal to 18 minus W, I'm going to bring that and put it in this equation. Instead of L, I'll have 18 minus W, open brackets, W is equal to 80. Then when I expand this out, I'll have 18W minus W squared is equal to 80, right? Now I have a quadratic equation, but I just need to rearrange it, and I prefer if this w squared is a positive. So I'm going to go to my next page. I had 18w minus w squared is equal to 80. I'm going to bring everything this side because then it will be positive. So that means I'll add w squared. That means I'll subtract 18w. So I'm going to have 0 this side is equal to 80 plus w squared minus 18w. And then if I rewrite it properly, w squared minus 18w plus 80 is equal to 0. Alright, so I have a quadratic equation and I can now simplify it using the ideas that we all approach at. So w, I need to add them such that I end up with negative 18. And yeah, so start asking yourself what are the factors of 18, sorry, the factors of 80 that can give me that I can add, that I can multiply or manipulate to give me 18. So let's try and see. Actually, this video has already gone on long enough, so I'm going to ask you guys to complete this problem as your homework, right? So you complete this problem and obviously write down all the notes. I hope you've been writing down all the notes and example problems in this video. And that will be it for today. I was going to give you this homework, but we will do this tomorrow. So don't do this today. This is for tomorrow. Today, just complete this video. Okay, bye.